So as I said, I would be a little bit like a crippled guy because I like to wave a lot. Although I'm a Bulgarian, I'm actually more like the Italians when it comes to talking. I wave a lot. Any Italians here? Okay, so I'm gonna say something about Italians. Please don't get offended. I love you guys. Actually, I love Italy. This is the place where I proposed marriage to my wife in Florence. But I'm gonna try to tell a joke, although I read very bad. Tower. Do you hear the voice now? Okay. So you know that they wave a lot, the Italians, I mean, and the mafia catches one Italian guy from another mafia family, and they get the guy to a dungeon. They tie his legs to a chair, tie his hands at the back, and they start beating him. His mouth is also with duct tape. They start beating him, and from time to time, they open the mouth and ask, tell us some information about the other family, please tell us. And they continue beating him because the guy constantly is not talking. He's like so, tied with the hands and everything, trying to say something, but he's not talking. Although from time to time they open the duct tape. They beat the shit out of him. And at a certain point, they say, okay, let's just ask for the name. Probably he has something rock solid, manlyhood, so this is why he's not speaking. Let's just ask him for the name. They, again, open the duct tape. Please, man, tell us at least your name. We beat the shit out of you and we will continue. He's again like, then one of the beaters says, okay, let's untie his hands. He's showing us something. So they untie his hands and he goes like this. Vincenzo! Mi chiamo Vincenzo! So yeah, I'm like a little bit like Italians. I wave a lot and I think I'll give this mic another chance and then I'll leave it for good. So guys, actually this is me. My name is Ventsy. I'm from a company called Zingasoft. And yeah, I'm giving this away. Sorry. I guess it is better so we can communicate instead of have the recording after all. So I come from a company called Zingasoft and I am here just to talk about Azure. It is a cloud technology that I love. And of course we're on a nopCommerce conference, so I'll be talking about how you can deploy nopCommerce in Azure. But before anything, because there was some mess up, at least this is how I perceived it in the morning, about which session is at which track, let me give you some expectations about the session. In order to fully benefit of it, you should be at least technical, preferably developer. You should at least have some basic concept about what Azure is. Preferably at least know some services. If you are an expert, most probably the things that I will show you, you will already know. So please reconsider your staying. I value your time. If you don't think that this is the right session for you, I won't take it personally. Everyone can leave and go to the next room. But if you're still convinced that this is the right session for you, my goal is to give you a couple of services as examples that you will definitely need if you want to deploy on Azure, and show you a couple of optional architectures that kind of tie the services one to another. And after the end of the session, hopefully you will have something like a guideline, like subsequent steps, which give you an idea what you need to do when you want to deploy on Azure. That's the whole idea around the session. It's not a session around whether you should go on Azure and give you arguments. It's like, if you decided to do so, let's see what we need to do. I divided the whole conversation into a couple of sections. Briefly, I will mention some things more about me, about the company I work for. Afterwards, we will kind of lay the foundation, a common ground in the knowledge we have about Azure. And this will serve us for the focus point that we have afterwards, which is not on Azure. And this focus point, I also divided 3 times. We'll start from deciding what's the necessary architecture before deploying. Then once we figure out this, we will decide based on the load that we expect what the capacity of our system needs to be. And afterwards, I will share some, I call them tips and tricks, but this is like moreover extensions of our capabilities through the cloud that we met in our practice, and I hope you find it useful. Proceed. At the end, at the real end of the presentation, I have some points which I consider the most important out of the presentation. I will try to be fast so that we can be first to the lunch. I know that I'm the one standing between you and lunch. Yeah, so let me get to the point. We are a small company, born a year ago, during the so-called cliche company born in the cloud, because we heavily rely on cloud services and we don't invest in infrastructure. Azure is one of the services that we use not only for ourselves, we use it for our customers and the solutions that we provide for them. We perceive ourselves as a company helping non-technical firms enter into the digital era by saving them from the burden of knowing every single technology that's produced in the world. We try to give them the software necessary for their needs to do the business. Of course, we are a nopCommerce conference, so we do nopCommerce, and it's one of the things that we do. Actually, we specialize in cloud development, in web development, mobile development. We recently started with Xamarin. All this is based on Microsoft Stack, Dev, and Tools platforms. And that's us as a company. Me, and personally, I'm one of the co-founders. Before that, I used to work for a company called Microsoft for 4 years. Before that, I was freelancing primarily for New York companies, and well, before that, I was a developer for another Bulgarian company. So pretty much, roughly, I've been for the last 10 years and a little bit more in the software business. So this is just to give you a perception if you have something aside from commerce where I can be potentially helpful. And before going to the Azure part, one ask to you guys, I believe that we are all here to benefit of the common knowledge that we have. So please, let's make it so that the whole session is not a monologue from me towards you. If you have some experience with Azure, if you have some questions, please do interrupt me, share whatever you would like with the audience. We are here to learn. I'm here also to learn from you. Azure and cloud technologies. How many of you have some perception, have some knowledge about cloud technologies? Great. Anyone daring to give his like explanation of what cloud is? Come on.
Put your servers on your computer, put your files on a server somewhere far away.
Yeah, I agree. Anyone else?
New Microsoft Azure. New way of Microsoft making money.
Yeah.
That's all. We're doing it all.
Yeah. Back in months, years ago, I was explaining what cloud is by giving an example of evolution of technologies. Let's say 20 years ago, people had to manage everything inside their office or data center. Everything I mean hardware. Later on came virtualization, which opened the way for some companies to do new business models and give away, of course, for money, computing resources. This is the time when we started speaking about infrastructure as a service, then platform as a service, software as a service. It's kind of a complicated explanation, the one I used to give. Recently, I started thinking to myself, if I have to explain, even to a non-technical person, what cloud is, how should I do so? And I don't know that if I'm correct, but I came up with the following explanation. It's something for me as a developer that gives me an economically efficient way to rent computer power when I need it and to release it when I don't. That's it. What's computer power and storage? Now it depends. And when we talk about Azure, it's the following. I know you don't see anything, I'm sorry. I'm sorry. We'll see how we can fix this in a minute. That's not so important at the moment. What you see is probably 10, 50 services of Azure divided into different families. But actually, when we are talking about NOP, we don't need all of these. We just need part of them. And to be even more specific, we need to know just 3 services from Azure in order to start deploying NOP on Azure. Which are these? I'll try to show so that everyone can see. Any better at the back? So I'll explain it like this. This one, this red rectangle is the Azure portal, which is like a web-based control panel. Please interrupt me if I'm talking very simple things for you. If you already know it, then it brings you nothing. So the Azure portal is where you would, in a web-based environment, define what services you need from Azure. Then, continuing from what you need for NOP, we will go to web apps, and this is the service that we use to host our web application. It's something like a virtual machine on a more abstract level that has the Internet Information Server, that has .NET Framework installed, and on top of that, similarly, like hosting, you put your web application. It's not exactly hosting, it's a more modern, more flexible thing, but yeah, this is a good similarity. So this is web apps. And the other open question that we have for NOP is where we put the relational data. And that's something called in Azure SQL database. It is Microsoft SQL Server, but provided as a service. So there is another abstraction on top of the server. Once you figure out these 3, once you get acquainted with those, you're able to deploy your first NOP and start running it. But if you want to make your life easier, if you want to make a better solution on Azure, then you need to know a couple of other things. Starting again from the top, what you see over here is Visual Studio Team Services. And all these yellow, orange rectangles are actually optional for you. But we use them, for example. Visual Studio Team Services as the top is the service that can give you a way to store your source code. So it's from one side repository. You can use either Git or TFS, whichever you prefer. It's free for 5 people. Then, apart from that, with this service, you can define build automation, you can define continuous integration, you can define your project documentation. Actually, no, your project structure, your sprints, if you're Scrum, track your issue, etc. Many things. We find it quite useful. Now, because one side of the story about NOP is web application, if you need some detailed telemetry data, how the web app performs, you can use something called Application Insights. I will mention it in more detail, probably somewhere at the end of the presentation. There is another service that we use called Scheduler, and this is for the occasions when you need to keep your site alive, even though it's not frequently accessed. You know that if you don't hit your site within 20 minutes, Internet Information Server closes the process. So we solve one of these problems with Scheduler. Then we use another service called Automation. Again, I'll be mentioning more details about it later on. And with it, we write PowerShell scripts to automate the management of some Azure services. And the last thing here, we'll give you the answer if you want to go really deep with nopCommerce and you want to have something like a distributed system where you would put the in-memory caching and the file system storage. This is Redis cache and storage, respectively. So these are actually the services that you might need to work with NOP on Azure. Any questions so far? No? Yeah, let's continue that. So as I said, once we lay this foundation regarding Azure, and we have some common knowledge, then we'll get into the NOP aspect of things. And the first section of it is deciding what the architecture would be. Here we have a couple of options. The simplest one is the first one, animation broken. The first one, which is have a single web application, which is tied to a single database. As easy as it is to implement, to spin up in Azure, the issue that you might face here is the answer to the question, when I need to go big, when I'm under heavy load, what do I do? And the only answer here is you kind of have to increase the capacity of your web server, your web app service, and you have to increase the capacity of your database. One or the other or both. But there are some other ways that you can implement your environment. You can have again single database, but now you could have a web farm servicing all your requests. And on top of that web farm, there is automatic load balancer, which distributes the requests coming towards the farm. This way, now you can not only scale by the capacity of a single web app, single web instance, you can also scale horizontally, so multiplying the copies of your web application. And there is even another more advanced scenario where you say, well, now I'm not only distributing the requests that are coming to my instances of the web farm, I also want to export into a central place the file system storage. And it goes to this storage thing over here. And I also want to export the in-memory caching of each and every instance in Node to a central place above, which is called Redis cache. Anyone heard about Redis? Awesome. Okay.
Can you explain it? Just briefly what Redis is?
Redis is an open source project which provides you with the capability of spin up a server taking care just for in-memory data that you want to keep close to you and use it like caching. The thing is that Microsoft did so that they embed the Redis as a concept and as technologies, and they provide it to you as a service. So you kind of go to the portal and say, I want this caching server. Then Microsoft, once you spin it up, give you the keys to use it, and you use it in your code. That's how it works. And actually, these are the three meaningful options in terms of architecture that we found during our experience with OpenAzure. They are not all that you might think of. There are some others. But if you want to be fully cloud open, I think these are the most sensible ones. Any questions here? Yep.
So Redis is actually used for distributed application?
Yes. What happens here is that each single instance does not keep into its own memory the caching data. It's putting the caching data into this Redis server. And through this, actually all instances have one and the same data, which actually raises the question, do you see a problem in the middle architecture with this? What do you think happens if, let's take the following scenario. If somebody, a user to our nop side, hits this instance, and some caching is done inside that instance, but then this same user or another user hits another instance. Any suggestions? Any guesses?
No more caching. Next instance.
It's another instance. It's another instance. So actually here you have some kind of data cached in that instance, another kind of data cached in that instance, and another kind of data cached in the third one. So actually this works, by the way. You won't face any problems by the default settings when you bring it up in Azure. And the reason for this is that by default, when you do so in Azure, there is something called like an affinity cookie, and what it does is to stick the user always to a particular instance. But the negative side to this approach is that it's not a real load balancer. Once a request comes here from one user, you know that the user is always sticking to that instance, and it might get heavily utilized. So it's not a real load balancer. Yeah.
What happens if the customer is on instance 1?
Yep.
And the admin logs in on instance 2, starts changing the product. The admin interface validates the cache on instance 2, but on instance 1. So the first customer has seen all data. How does fix that?
So when it comes to the caching, it will invalidate on the single instance level. But there is another thing regarding the persisted data, which is either in the file system or in the database. There we are okay.
Yeah.
The database is clear by the scheme. It's one single one.
Yeah.
But the other question, okay, what happens when we put images from nop into the file system? Again, we have 3 instances. And the answer to this question is that underneath it all, Azure Web Apps, no matter the number of instances, are actually utilizing storage. So they all actually access one and the same thing. So in the second scenario, actually we have to be careful only with the caching. And it might work for certain scenarios. I'm giving it this as an option here because it's valid. But probably you'll be sticking either with the first or the third, depending on the scale.
That's why we need race.
Yeah. Now, this is another perception of the 3 scenarios, and this is more related to the cost and the capabilities of each of them. So if you want to go cheap, you start with the single instance one. You see the starting point is something like 12 euro to raise those services. If you want to distribute your instances and have multiple ones of those, you need to start with 50 euros a set, and so. If you need to bring Redis cache, you pay more, etc. So one thing I want to stress on, so this is the highlights, but there is highlights of the highlights, is this: if you really want to be cheap, please be careful with those 2 things. First, with the cheapest option, you're sharing your resources with somebody else. You don't have a dedicated virtual machine you need. And the other thing is that you might be required to encrypt your traffic. So if you are required to do so, you need SSL, which is not present in the first option. The good thing is that all the prices that you see above are for a service plan. This is a term in Azure, which kind of gives you an abstraction of an environment you have, and on top of that environment, you can put different websites. So, in other words, when I say 50 euro, it doesn't mean 50 euro for one single website. It means 50 euro for the environment we need, and I can put as many websites as I want, having in mind that they compete within that environment for processing time, for memory, etc. So, probably somebody's scratching his head and telling himself, okay, if I pay more, I get more. Is that what you're telling me? Yeah, I'm sorry guys, that's the reality of the world. No change there. Now, once we've cleared that out, what are our architectural options? The next thing we need to solve in our design is try to decide what the capacity of the system will be. In other words, how strong we need to be to meet the demand of our users. And I'm leaving the storage aside of all the components that you saw in the previous screen. And actually, the few things you need to be careful are Redis cache, and it's the easiest one, I'll tell you why. Then database that you utilize, and the app service environment. The size, the capacity is decided by something called tire. Now, why the Redis cache tire is the easiest one? Because you have multiple plans to get Redis as a service, but what you should be careful with is that the first, the cheapest plan does not give you any SLA, does not give you a dedicated instance of Redis. You're competing with somebody, and bottom line, it's not ready for production. This is what you need to know about Redis. Now, as for the rest, let me switch to the Azure portal and show you what I mean. For those of you that haven't seen Azure portal, that's it. Here's the place that I can bring up some new services. I can manage and monitor my services that I've already spinned. And for example, I can go to all resources that are currently running. I will filter nopCommerce, and I will open my database. What I did now, for demo purposes, is that I've created a production environment with nopside, and inside it we have roughly around 200 products. And I also created one development environment. Now, we are looking at the database for the production. And here is the tiring stuff that you see. If you want to bring up a database in Azure, you have to define which of the plans that are available you're going to stick with. And you can change this dynamically. It's okay. Nothing's wrong there. I want to be cheap, so I started with something really suffocating the system. This is 5 BTUs. It costs really small amount of money. And actually, what's it yield, right? Yeah, what's it yield? So this is the measurement for the capacity of our database in Azure. It's called DTU, Data Throughput Units. Actually, it's something like a blended measure, combining in itself CPU performance capability, memory, and this creates writes. And I don't know, I don't think it's publicly shared how exactly the DTUs are tied to each other for these components. But most importantly, what they guarantee us is that if you go with 5 DTUs and then you decide to change to 10 DTUs, you exactly double the capacity of your database. So for example, if you go with 1 tier, you make some testing and you decide that it's not for you, you can see how times that will go up and down. And how do we do that testing? Anybody did some load testing with Visual Studio? Yep. Okay, great. So probably it's worth showing it to the rest of you guys. Once you go to Visual Studio, you can create a project like any other project, going to File, Open New Projects, and then what you have here is a category called Test. Inside that category, you have something called Web Performance and Load Testing. Now, if you click this, it will generate a project, which I have somewhere else. So let me spin up another instance in Visual Studio. You will generate a project that contains something called Web Test. And that Web Test is the definition of the steps that you execute in a web browser, let's say. Come on. So hopefully we'll see it in a minute. It's alright, but while it is loading, it won't load because I haven't selected the right solution. I did nothing. Yeah, so what this generates is a project with one single thing at first, just this file, web test. And what you guys could do is come to the web test, open it, hit this button, which is record. Afterwards, it will raise an instance of Internet Explorer. You start clicking through your website. Underneath, it records your steps and save them into a file. And then you're done. That's a simple scenario. Once you are done, you come to your project and say, now that I have my steps recorded, what I want to do is go and add another project, which project is called load test. So in other words, now we'll be defining how many people will be using these recorded steps. What I did in this scenario is say, I want 50 simultaneous users to hit my website for 2 minutes and repeat the steps that I just did in the recording. This is the test that I have at hand. Let me run it. I'm running it now, and there is another interesting thing here. You can say, I want this test to be run through a data center in Azure in a particular location, or I want it to run locally. Currently, I'm running it through Azure. I'm minimizing this because what will actually happen after the test is, yeah, I wanted to show you why it makes sense to measure the performance. What will happen after the test is the following. I'm in almost the cheapest tires for web and database, and you see, probably, you see that I'm utilizing this test 100% of my database. Now, I was persistent here. I decided that I will continue. I will stick with the same level of web environment capability, but I will increase the capability of my database. Then, what I did is double the capacity of the database. Can you guess what happened? Again, 100%. One thing I forgot to mention on the previous slide. The peak of my response serving was for 3 minutes. So my server was responding to the user for 3 minutes at its peak time. Now, when I doubled it, what happened is that the database was again utilized fully at 100%, but now this time dropped at 17 seconds. So things are becoming faster. And I decided I will continue until the metrics of my database are okay. I doubled it once again. Can you guess what happened? Again, 100%. But then again, the time is stopped. I have just 4 seconds now. I continue. And now, I was fine. Relatively under 80%. And then what I had for my server response time is under 2 seconds. So this is a way for you to actually test the performance of website. 50 users might sound not a lot, but this is, let's not forget, 50 users simultaneously. These are not 50 users being online on site. These are 50 users constantly making requests, which for nopCommerce would mean that every second we have something in between 2,050 and 5,000 requests hitting my server. So you see 100%, but it's a lot hit as well. So the other conclusion that you could make here is that when you deploy on Azure, you have to be really careful with your database. The other side of the story is to know the limits of your web environment. Similarly to the database, you have web environment tires, and let me switch to the screen here. I will close the database and I will open my website, which is here. I'm not explaining everything in Azure, but I do so intentionally. I don't need to bother you with site stuff. This is the control panel. So from a certain place, I can come and see what's the tire I have for my web application. And currently, I'm on this cheap one called Share, where I can just have custom domains. If I go a little bit above, I see that I have some dedicated infrastructure now with certain CPU, certain cores, RAM storage. I have now SSL support, etc. So similarly to the database, we have tires here. You can use just for 60 entire minutes, which means when a request comes to your server probably takes up a couple of seconds to serve the request. This is part of these 60 minutes. Then another request, some other seconds, and this is how you add up to the time you have, limited time. You have a little bit more time with the share, and the other very important thing to know is that again you're in your shared environment, so competing with somebody else. You're not in your own virtual machine. Any questions so far? Yep.
How do you compare the website versus the cloud services on Azure? You can create a cloud service and deploy your stuff in cloud service. It's a different animal, slightly.
Yes. Yes. With cloud services, you're always stuck with your own environment. So you can reckon that your first mobile phone, your guarantee is on performance. They're more expensive, by the way. You have a little bit more control on cloud services compared to websites. But honestly, during the past couple of years, let's say 2 or so, cloud services are quite falling behind compared to web apps. I'm not sure that if there is anything that web apps can do and cloud services can, or vice versa. I think that web apps, bottom line, are replacing cloud services. So the recommended way is do it with that web apps.
When you change from either the database or the app from one scale to the next,
Yeah.
how long does it take for it to kick in? Is it immediate?
There is a drop down time if you have single instance. If you have multiple instances, you can drop down time couple of seconds.
Oh, okay.
It's rolling. Yeah.
So
It's
so
not
if you do it and you go
intensive.
after a minute and you're testing, you should see.
Yeah, exactly.
It's not like it's copied
It's
the
less
whole
than a minute.
database somewhere else.
It's less than a minute, again, compared to your own environment. This is in the particular case of time. But if you don't want to have any downtime at all, you need to remove instance. Now, why is this important, actually, to know your database tires, to know your limits of the web application? Because we had this particular case when started deploying Nop on Azure. Don't pay detailed attention to the screen. Pay attention to the bullets. What we did following the Azure guidelines is start with an environment that can give us the ability to have production side, test, and dev. And underneath we needed 3 databases. We needed some storage. And my question to you guys is, do you see something wrong in that picture? Focus on the bullets. Anything wrong? Let me help you. Right? So this is what we did following the guidelines. But after getting acquainted with some of the services, we found a way for our particular case back then to circle around these services and come up with a different environment that cost us, if the previous was roughly 140 euro, this is how much? 8 is 4, 12, 14, 26, roughly. So you see what the difference is. This is why you have to know your environment and the limits of capacity. Now, we've decided on the architecture. We're acquainted with the capacity that we need to provide. Let's see if we did everything before, everything that we just showed, what we can do more in order to make our lives easier. And I'm starting with this thing called automation. Let's see how much time we have. Okay. I'm starting with this thing called automation. And I'm getting back to my web app just to show you something. When you go to your web application, you have something called backup, daily backup, that you get out of the box. It is similar with your database. But if you go cheap, you don't have that backup. And that was an issue for us. So what we did is utilize another service in Azure, which will give us the ability to write PowerShell script and automate the backup, which otherwise would cost us, let's say, 30 euro. We automate it in such a way that we make an export from the database, and then we put it into the storage, and this cost us not cents, tens of cents per month. Let me show you the PowerShell script. I'll briefly introduce you to it. No, sorry. So it's a really simple script. At the top of it, I'm just getting an account that has access inside my Azure stuff. Then I'm defining some variables that I will later use. What I do with the following lines is here to export my database, to make a copy actually. Then I will have to check with that while cycle. I don't want to spend the time to explain the syntax. That's why I'm explaining it briefly. I'm checking if the backup of my database is done. Then I'm exporting it to storage, and then I remove the temporary backup of my database. I need this temporary backup so that I make sure that I'm not exporting something which is breaking transactions. This is why I'm first making a copy. And we put this into storage. This is how we solve one of our problems in Azure. The other thing was, now, once we can save relational data and the copy is there, what we need to do is save the file system data and make a copy of it as well. For the same reason. Otherwise, it's expensive. What we utilize there is something called web job, and this is even easier for you to implement. I'm closing this guy. I'm opening my NOP solution. What you need to do here is just come to the website of the NOP solution and say that you want to add another project of type new Azure web job project. This creates a sample project for you. Let me do so. And before it's generated, we have to tell what's the name of my web job, should it run on schedule, okay. How many times should it run, it's recurring, without end date, starting from today. That's okay, it generates some code. And inside that code, what you do is just to say I'm hitting a REST API for my app service, for my website. I'm getting an archive of the file system, and then I'm pushing it to the store. I can show the code actually. So what you do have here in that new project is just an application configuration where you have to point the storage that you have. You have to give it a connection string to the storage. You have a really simple function that is generated by the template, but let me delete this one and put another one. That's another function. And what I do here is, if you take a look, I'm just getting some configuration settings from my file, then I'm preparing a web request towards the REST API. After this, I'm just preparing my storage instances and do the job. If any of you wants to use that source code or that script, they're not rocket science, but they will save you some hours per test, just ping me and I'll give it to you. It's not something secret. And this is how you solve the problem with backing up your file system. Now, afterwards, you can use something else, which is called application insights. When you use Azure, you utilize services. If you go to the control panel of Azure, what you see there are metrics and systems. What you don't know is how your application behaves. In order to do so, you need to run something called application insights. How you do this? You add a certain NuGet package into your solution, and then you set a certain key which is provided by the portal in the configuration file. It is exactly 2 minutes of work. You publish back your website to Azure, and you have that element. It gives you insight to the most heavy loaded URLs. It gives you insight about the exceptions that you might have, etc. It's really, really useful. So I recommend it to you. More to play with. Something called resource groups in Azure. This is something like a namespace. Inside that namespace, you can put one of your environments, let's say production, and give access to, let's say, one person. Inside another resource group, / namespace, you put your test environment, you give access to a wider range of people. Something called webhooks. The web job that I just showed you, when it ends, it might trigger a request to a certain URL. And there are services now that you can use to say, if this URL is hit, I want an SMS on my phone. Zapier is one of them. And it's very useful. If you start really advancing in Azure, and you start having multiple solutions, and you want to automate how they're rolled out, you don't want to go through the portal clicking. What you could look at is something called resource manager templates. These are JSON strings that define your environment in Azure, and you use them to deploy your new resources. And something very, very, very important. We bumped into in a couple of cases we were, how to put it, lazy. When we could, which cases we could avoid using alerts in Azure. For example, we had a case when we hit the limits of our environment and the website stopped for customer hours. There was another one, which was Azure Services stopped, and it was announced on the page, respectively, what we used also stopped. Again, hated from the customer and bad emails, etc. There is another one. We release a web API project and we use a certain authorization mechanism there, and apparently broke half of our API methods. We didn't find out this in the beginning, but the server was returning 500 something error, and we could if we used alerts. What are alerts in Azure? And this was one of the final things that I'm going to show you guys. Alerts are when you go to your web app settings and scroll somewhere down, you can say, I want to up a new alert for my website. I'm going to give it some name, it doesn't matter. And here I define what's the metric that I want to track. Let's say that I want to track what's the CPU percentage that's utilized. And under a certain circumstance, let's say it's greater than 80%, then I want to be notified so I can take some measure. So that's what alerts are in Azure. And it's definitely worth using it. Knowing that, actually there are a couple of things that I consider kind of summarize the whole talk. When you need to go to Azure, don't just go ahead and deploy with whatever you have in Azure. I just want to mention here the relatively different services and how they tie into an architecture. That's first. Second, you saw what's happening with the database, be careful there. Measure, know what the expectations of the customers are, and then decide. Know the limits of your tire, because you can mess things up with big money. And once you're up and ready going, try to experiment with different services so you can make your life easier. Actually, this is all from my side. If you have any questions, comments, whatsoever, I'll be happy to discuss. No? Thank you guys.